So what is action potential? So potential tells you that it's something that could happen, and when that potential is met, there's some action that occurs. So what's going to happen here is that the nervous system works really well with the muscle system. And if you remember back from our muscles chapter, there was this thing called a neuromuscular junction. And it turned out that electrical energy got changed into chemical energy, basically released some chemical energy, those neurotransmitters, and then went ahead and carried that electrical energy again. And it was always done with certain ions. So these neurons of these muscle cells are excitable, and voltage could change to cause some stimuli. And these depolarization events occur. Now, keep in mind, depolarization is not a scary word. It just means that one side of the cell is going to be positive and one side of the cell is going to be negative. And when those charges sort of exchange from one side to the other, it's called depolarization. Polarization by itself would be when they stay on separate sides. So depolarization of one area of the cell membrane leads to the other. So we're going to be talking about things in our body that have charges on them. And there's some things called cations. Cations are positively charged particles. So those are going to be like sodium, potassium, and anions are going to be negatively charged particles like chlorides. A lot of proteins inside of our cells already have a negative current, like the endoplasmic reticulum, the rough ER. A bunch of the organelles inside the cell are slightly negatively charged. So that makes it so when things on the outside are positive, they really want to get in. And we're going to have to keep them out or control how they come in and out, because that controlling of those ions going from one side of the cell membrane to the other is what we're going to be talking about, that polarization. Voltage is a measure of potential energy, and if you look at the battery, you'll see that there's a positive end and a negative end, and they could sit like that for a really long time. The only time the battery really starts to have issues is when you connect something to both sides. So usually a wire, and that makes it so the current, which is the potential energy and voltage, can do some work. So like you'll hook up that wire to a bulb, and then you'll hook up the other side of the wire to this side, and then of course the bulb will light up. Our cells are very similar. So here's the outside of the cell. Here's the plasma membrane, and then here's the inside of the cell. Our inside of the cell is slightly negative. The outside of the cell is positive, and what happens is these positive ions really want to get in. And the only way they can get in is if we open up these special gates that we'll start to name later. And that's going to let these guys go from one side to the other and change that voltage. What is it called when the voltage is, there's one positive end and one negative end? It's called polar. And then when those voltage or those charges change sides, basically that's going to be that depolarization that we talked about. Current is the movement of charges from one location to the other. In living organisms, that's just going to be those ions, those cations and anions going from one side of the cell to the other. But your laptop, so many things are controlled this way, where you have the positive and negative ends come together and it's going to charge something or make something work. And we know that if you think about magnets, if you take two positive ends of that magnet, they're going to repel each other. Same thing as two negative ends, they're going to repel each other. But positive and negative ends come together and they attract. So what will happen is that if we put a cell membrane right in the middle over here, we're going to have this thing occur where positively charged ions are going to be on one side, really want to get in. Negatively charged ions or really want to get out, to kind of meet together to be attracted. But because the lipid bilayer is in the way, they can't do that. So the only way they can meet each other is if there was some sort of protein that will allow some of these to come in or some of them to move across that membrane, and we'll talk about them soon. So that is called the membrane transport mechanism, where we have these channels that can allow those ions to cross. They do it based off of simple diffusion. Remember how simple diffusion is high concentrations of items want to go to where there's low items until they get to equilibrium? Well, it really wants to do that, but we artificially separate these two out, and it requires a lot of energy to do this. So if you remember way back in the day, that's going to be active transport, where we're going to have to use energy to separate these out. So we have a high concentration on one side and a high concentration of another ion on the other side of this membrane. So they both, if they get the chance, want to go to the other side so they can get to equilibrium. Also, it's going to help them with their charges, but they're artificially kept from one side to the other through these channels. So the next thing is these facilitated diffusions require certain channels or proteins to let the ions travel to the other side. And there's a couple of kinds that we can do. There's the ungated, which are called leaky channels. They're always open. And then there's the gated. Gated are going to be closed unless they're opened. And usually the kind of things that'll open these guys are going to be either another charge, maybe a hormone, or a chemical. So ligands are something that is a protein that when some specific item comes and attaches to it, it's going to open. So a ligand is kind of like a key, and when that protein and that key come together, that channel will open. Another type of gate that opens is called a current. So that's going to be a voltage gated channel. So when some volts change on one side of the cell to the other, the voltage itself will open the gate to allow those ions to go from one side to the other. And again, the movement of ions are going to be due to those simple diffusions from high to low, and of course those positive and negative attractions that most of these ions have. The things that we're going to talk about after we get past this little action potential energy is we're going to talk about different types of gates or different systems that these guys can go from one side to the other. There's one for sodium. Remember, it's positively charged. And potassium, it's also positively charged pump. And they're going to basically move these items from one side of the membrane to the other. There's a potassium leaky channel. There's a sodium leaky channel. And then there's two that are controlled by energy, voltage gated potassium channel and a voltage gated sodium channel. And then finally ligand. Remember, that's like a key, and that ligand opens up a channel, so it's called ligand gated sodium channel. So here are the overall steps. I more than imagine that this is going to be a question on the exam that you might have to label and talk about each of these steps. So let's do that in our next video. Let's cover all of these steps in our next video.